Okay, so the first part is going to talk about factoring each of the following, but it's going to be by finding the GCF first. So basically, the first part is you're going to factor by using the GCF. Okay, so let's go number one. You have 21x minus 15y. So 21x minus 15y. So you have this polynomial. And how many terms do you see here? Two. There are two terms. You have 21x and a negative 15y. What do those two terms have in common and the greatest common factor? What do you think? 3, okay? 21 goes into 3 and 21 goes into 15, right? Now, in terms of the variables, am I going to have any variable in my GCF? No, because why? Both terms don't have the same variable in common. Okay, good. So the GCF is only what? 3. All right, GCF is 3. All right, if you look at that handout that I gave you today, if you look at this one here, so once you find the GCF, remember factoring means you're going to write as a product. When you factor, you're going to notice that when we factor, we write things as a product multiplication. So when you find the GCF, you're gonna take that GCF and you're gonna multiply by a parentheses that has terms in it, and if you were to multiply it out, you would get this back. So again, what's the GCF? 3. So you're gonna write this as 3 times. Okay, now how many terms did you start with? 2. You better have 2 terms inside the parentheses. And basically, you can always check yourself by using the distributive property. 3 times what is 21x? 7x. Minus 3 times what is 15y? 5y. And so there's your answer. Okay? If you look at 7x minus 5y, there's nothing else you can do there. They have nothing in common besides 1. Okay, so when you have a GCF other than 1, you're going to say GCF times, and what's inside the parentheses when you multiply by the GCF, but to give you this original back. Okay, number 2. All right, 2, suppose we had this. 7x to the 5th minus 2x cubed. 7x to the 5th minus 2x cubed. What do y'all think the GCF is here? Huh?
It's 2x.
So you're saying that 2 goes into 7 evenly?
Oh, no.
No, it can be 2. What is it?
1. No, it's just, it's x to the 3rd.
It's x to the 3rd, yes. X to the 3rd. They both have x's in common, right?
Mm-hmm.
So on your worksheet you have to turn in Tuesday, if I gave you x to the 5th comma x cubed, and I asked you to tell me what the GCF is, what's the GCF of those two terms? X to the 3rd. So the GCF here is x to the 3rd.
Why is x to the 3rd?
Because you take the one with the smallest exponent. They both have x in common. When we did number 1, you even said there are going to be no variables in the GCF because they have no variables in common. So they both have variables in common, the variable x. So you better have at least one factor of x in your GCF. But now you know you need at least 3. You need 3 actually. You need 3. So then you're going to say the GCF, and what's the GCF? X cubed times, all right, now the distributive property. X cubed times what is 7x to the 5th?
7.
Why are you saying 1 times x cubed is 7x to the 5th? Who said 1?
7x to the 2nd.
7x to the what? 2nd. You're not going to say 1 because x cubed times 1 is x cubed. What did I want? 7x to the 5th. So and remember using using the product rule also. Product rule basically says that if I have something like x to the 8th times x to the 4th, what's that equal to? X to the what? Guys, when you multiply like bases, what do you do with exponents?
X to the 12.
You add them. So x to the 4th times x to the 8th is x to the what? 12. So using an idea here, x cubed times x squared is what? X to the 5th. Okay, minus, and what's going to go here? X cubed times what is 2x cubed? 2. You're not going to say x, because what's x cubed times x? X to the 4th, and that's not what I wanted. Okay? All right, number 3. You have 14x minus 21y plus 7. How many terms do you see?
2.
I don't see 2. How many terms do you see?
3.
3. What's the GCF of those 3 terms? 14x, negative 21, and 7. What's the GCF? 7. 7. You're not going to say any variables either because they don't have all the same variables. But 7 goes into 14, 7 goes into 21, and 7 goes into 7. So the GCF is 7. So then you're going to say 7 times. All right, how many terms did you see to begin with? 3. You better have 3 terms inside the parentheses. 7, distributive property. 7 times what is 14x?
2.
7 times 2 is 14. Is that correct? 2x. Minus 7 times what's 21y? 3y. Plus, and then 7 times what is 7? Huh? 1. So there's your answer. Notice I use a distributive property to help me get this. Number 4. Number 4, suppose we have 15x cubed plus 9x squared. 15x cubed plus 9x squared. What's the GCF? 3? Just 3? Huh? 3x squared. Okay, so take the one, in terms of the variables, take the one with the smallest exponent. Because x squared goes in x squared, and x squared goes in x cubed. But x cubed does not go into x squared, so that's why you can't use x cubed. There's not enough factors of x for x cubed to go into x squared. So then you're going to say 3x squared times, all right, times what? 3x squared times what is 15x cubed? 5 what? All right, so she says 5x cubed. Let's see. What's x squared times x cubed? Yeah, so it's just 5x, right? Okay, so see, if you put 5x cubed, you better check yourself, because if you leave it as 5x cubed, I'm going to say you did not check your work. There's no reason why you should get this wrong if you check your work using distributive property. Plus 3x squared times what is 9x squared? 3 only. Not 3x. If you said 3x, check. What's x squared times x? X cubed. That's not what you wanted. All right, so there's your answer there. Number 5. Number 5, suppose we had this. Suppose we had 12x squared y minus 42xy cubed plus 48x cubed y. So 12x squared y minus 42xy cubed plus 48x cubed y. All right, first thing you always need to do is find the GCF. So let's look at the coefficients first. 12, 40, it's negative 42, but let's just do 42. 12, 42, and 48. What's the GCF? 6. All right. And you can check it, because look, 12 is 6 times 2, right? 6 times 2. 42 is 6 times what? Do I need to bring a multiplication table in here? 6 times what? Guys, 42 is 6 times what? 7. 48 is 6 times what? 8. Okay. Now look at these right here. Besides the number 1, do they have anything in common? No. So what's the GCF? 6. GCF is 6. Okay. For those numbers, right? Okay, now what about the variables? 6x, okay. And what else? Y as well. So what's the GCF? 6xy. 6xy is the GCF.
Oh, okay, that's why, okay.
All right. So you're going to say 6xy times, all right. 6xy times what is 12x squared y? Okay, I agree there's a 2 because 6 times 2 is 12. And what else you said? X, because x times x is x squared. Someone else said y. Y times y is not y. What's y times y? Y squared. So I just need this to be what? 2x. Okay, minus 6xy times what is 42xy cubed? 7 y squared. Very good. 7y squared. No x in there because x times x is x squared, but I didn't want the x squared, I wanted an x. Plus 6 times what is 6xy times what? 48x cubed y? 8x squared. I agree with that. And so there's your answer. Okay? All right, number 6. So number 6, suppose you had this. All right, let's suppose we had 13a cubed b squared plus 39a squared b minus 26ab to the 4th. So 13a cubed b squared plus 39a squared b minus 26ab to the 4th. What do you think the GCF is? Always look at GCF first. Huh? Okay, so let's look at coefficients. 13, 39, and 26. You don't think it's 13? 13 times 3 is 39. 13 times 2 is... Guys. I need to bring the addition tables in here. All right, so GCF will be 13. What else? A. Not a squared because I don't have enough a's right here. A and what? B. All right, so if you said a squared, you got to be very careful. You better make sure that you have at least 2 factors of a in each one of these. And I don't because I only have 1 factor of a here. So it cannot be a squared. All right, so then you're going to say 13ab times, just like we did before. All right, 13ab times what is 13a cubed b squared? A squared b. All right, I agree with that. Because a times a squared is a cubed, b times b is b squared. Plus 13ab times what is 39, that's a 9, 39 a squared b. What do y'all think? 3a? Okay, I agree. That's it for that one. Minus 13ab times what is 26ab to the 4th? 2b cubed. So there's your answer. All right. Okay, now number 7. Now, when you look at number 7, that idea is going to be important when we talk about grouping. Number 7. So number 7 looks like this. You're still looking for a GCF, but it's going to be important when we talk about grouping. But it looks like this. You have x times x plus 5 minus 2 times x plus 5. So go ahead and write that down. So when you looked at number 6, how many look number 6 now? How many terms did you have altogether? 3. You had this term, and this term. Okay, and notice this term was made of a product of factors. This was a product of factors, and this was a product of factors. You can use that same idea with this one, although it looks a little weird, a little different. Here, I'm going to underline, just show you right now, I'm going to underline this, I'm going to underline this. And if I cover this part up, isn't this a product of factors?
Yes.
What are the factors?
2x.
Remember, factors are separated by a multiplication symbol. So if I read this, I read it as x times what? X plus 5. So your factors are x and, no, not 5, x plus 5. X and x plus 5. So together, just like this, as these were all factors right here, 13 and A, there were 3 factors of that, and B, there were 2 factors of that. Same thing here. So this is considered a term. So if you look at this term, how many factors do you see? 2. What are they? X is one of them. What's the other? X plus 5. When I look at this term, how many factors do you see? 2. Now, this is really a negative, but -2. But if I covered it up, you see a 2, and what's the other factor? X plus 5. Together, notice those 2 terms, they have something in common. What do they have in common? X plus 5. So my GCF is x plus 5. All right, now when you rewrite it though, remember it's always the GCF out in front. So my GCF is x plus 5. That's got to be put in parentheses. Because notice what you had. You had parentheses, right? So you can say x plus 5 in parentheses times, that's your GCF, times, all right, now, when I look at this, how many terms did I underline? 2. So I better have how many terms inside the parentheses? 2. Use distributive property. X plus 5 times what is this right here? What do you think needs to go here to get this right here? X plus 5 times what is this? X plus 5 times 1 is x plus 5, right? But that's not x plus 5. That is what? X times x plus 5. So x plus 5 times what gives me this? X plus 5 times what gives me this? X. X. X plus 5 times x. Isn't that what this is?
Yeah.
Okay. Minus x plus 5 times what gives me this? 2. There's your answer. So the answer is x plus 5 times what? X minus 2. It's really what you see. So technically, you're factoring this out, right? So what's left? X. You're factoring this out. What's left? Minus 2. Distributive property. X plus 5. If I distribute, guys, see, you're not looking at this. If I distribute, don't I get x plus 5 times x? Isn't that what this is? Okay, minus, and then x plus 5 times 2, right? So when I distribute, isn't this right here, x plus 5 times the -2, isn't that this right here? All right, you got to look like that now, because we're about to do grouping, and you're going to see this idea in grouping. You're going to see this all over again. right, so let's do another one. Looks like number 7. Okay, number 8. Suppose number 8 I had this. Y times x squared minus 3 plus 4 times x squared minus 3. So it looks a little bit different than the first 6. But it looks like number 7. So notice when I read it as y times x squared minus 3 plus 4 times x squared minus 3. So notice when I look at these two terms right here, what factor do those two terms have in common? X squared minus 3. So that's your GCF. So your GCF is x squared minus 3. So that goes out in front. That's your GCF. But you're going to put that in parentheses. X squared minus 3. Now you may say, well, why in the previous problems when I did the GCF I didn't put those in parentheses? And I did not. Did I put 3 in parentheses? Did I put x cubed in parentheses? Did I put 7 in parentheses? Did I put 3x squared in parentheses? Did I put 6xy in parentheses? No, I didn't. Because that was just one term. See, that GCF was one term, 3, x cubed, 7, 3x squared, 6xy. Here, though, it's not one term. X plus 5 is how many terms? X plus 5 is how many terms? 2. X squared minus 3 is how many terms? 2. X squared and negative 3. X and positive 5. Those are your terms. So you put those in parentheses. So my GCF is x cubed minus 3, so I factor it out. And so I get x cubed minus 3 times what is this first term right here? Y. Plus, and then x cubed minus 3 times what is this right here? 4. So there's your answer. So x cubed minus 3 times y plus 4. All right. Number 9. Suppose number 9, I had this. I had x times x minus 7 plus, and then x minus 7, just like that. All right, so I'm going to underline them just like I did before. I'm going to line the first term and the second term. Okay? All right, now before we go on, notice that for these that I had underlined, there's always something in front of that parentheses. X, negative 2, y, positive 4, x. But then I don't see anything here. What do you think that is right here? A 1. That's understood to be a 1. So when you rewrite this, just make sure you think of this as this. Okay, that's going to help you. So that's understood to be a 1. Okay? So if you need to, put a 1 there. So basically you would end up with this. Like that. You would just rewrite it putting a 1. All right, now that takes us back to the 3 we just did, or the 2 we just did. What do these two terms right here have in common? What's the GCF? X minus 7. So the GCF is x minus 7. So then I'm going to rewrite this as the GCF, which is x minus 7 in parentheses, times, and then what goes inside that set of parentheses? X plus 1. So if you didn't put the 1 there, you wouldn't know what to put. You would think it was just x, but it's not. It's
so
x.
nothing is right there, you automatically.
It's understood to be a 1. Yeah. Okay? All right. So we're going to come back to that idea in a little while. Okay, but number 10, let me just talk about number 10. Number 10, you're going to, there's a problem in my math lab that looks like it, and there's a problem on the worksheet that looks like it. So let's do one like that. So it actually involves fractions. So it's 1/3 x to the 7th plus 4/3 x to the 5th minus 7/3 x to the 9th. Okay? Now forget about the coefficients right now. Forget about the 1/3, forget about the 4/3, forget about the negative 7/3. Look at the variables. Do I have the same variable in all three terms? Yes, so my GCF is going to contain an x, right? Question is, how many do I need? 5 of them. So it'll be x to the 5th. That's going to be part of my GCF. So far, my GCF will contain x to the 5th. Okay, now suppose that the third wasn't there, the denominator wasn't there. Okay? And suppose I just had the numerators as my coefficients. 1, 4, negative 7. What is your GCF of 1, 4, and negative 7? 1. But since I do have the denominator, and all those denominators are the same, in terms of the coefficient, I'm going to use 1/3. 1/3. So the numerator 1 comes in the fact that the GCF of 1, 4, and 7 is what? 1. All right. Now, the one on the worksheet and the one on the My Math Lab, the denominators are the same. So it's 1/3. So this was, let's say, just showing you. Suppose, and we can do one, but let's suppose number 11 was this. Suppose number 11 was 2/5 x to the 8th plus 4/5 x to the 5th minus 8/5 x to the 9th. Suppose it was that one. In terms of the variables, what's the GCF? Just the variables. X to the 5th. All right, now look at the numbers are the same, right? So let's talk about the numerators. 2, 4, and 8, negative 8. What's the GCF of 2, 4, and negative 8? 2. My denominator is 5, so it'll be 2 what? 2/5. So that'll be the GCF. Okay? All right, now we're going to go back and do this in a little while, but let's go back to number 10. So what's the GCF for number 10? 1/3 x to the 5th. So it's going to equal 1/3 x to the 5th times 3 terms. Okay, so let's distribute a property. 1/3 x to the 5th times what is 1/3 x to the 7th? X squared. That's all you need, x squared. Because 1/3, this right here is 1/3, and this is 1/3, right? So do I need a number right here besides 1? No. And x to the 5th times x squared is x to the 7th. Product rule. When you multiply like base, you add exponents. Over here, though, what's going to be this term, do you think? 1/3 x to the 5th times what is 4/3 x to the 5th? 1/3 times what's 4/3? 4. All you need is 4. Because 1/3 x to the 5th times 4 is 4/3 x to the 5th. Minus, what do you think goes here? 7 what? X to the 4th. So there's your answer. Right, so 1/3 x to the 5th times x squared plus 4 minus 7x to the 5th. Multiply like basis, add exponents. 5 plus 4 is 9.
Don't worry about it.
You gotta use the product rule. X to the 5th times x to the 4th is x to the 9th. All right. Number 11. What do you think the answer to number 11 will be? It'll be 2/5 x to the 5th times, all right, 2/5 x to the 5th times what is 2/5 x to the 8th? X cubed, right? Okay. Plus 2/5 times what is 4/5? What do you think I need? 2. Good. All right, now let's talk about the variable. So, well, this is already x to the 5th and this was x to the 5th, right? So do I need a variable right here? No. minus 2 fifths times what is 8 fifths? 4. Okay, so I know I need a 4. X to the 5th times what is x to the 9th? X to the 4. So there's your answer. Okay? All right, so any questions on that part? Okay, so that's going to be this worksheet you're about to get.